In this series of videos, we're going to talk about the process of metamorphism and the metamorphic rocks that are created as a result of the metamorphism. In the background, you can see some very interesting rocks. What makes these rocks particularly interesting is the fact that they have all sorts of folding that's happening right in the rock. These metamorphic rocks, we're going to find out, are those rocks that are formed in those intense environments where we have heat and pressure that are also acting to deform our rocks. So we are back to the rock cycle. Earlier this semester we looked at igneous rocks. Then we talked about erosion, and we talked about weathering, and we talked about the transport of sediment, and ultimately we created our sedimentary rocks. What we're going to do now is we're going to take our existing rock types, whether it be igneous or sedimentary, and we're going to bury it or heat it or expose it to a lot of pressure, and in the process we're going to form metamorphic rocks. So it's the last of the three rock types that we have to talk about for this semester. And these rocks are kind of fun because they're wild looking. A lot of them have some interesting structures. Oftentimes they're fairly easy to identify because of those structures. Those structures get created in those intense environments. So we're going to start off with a pre-existing rock. We're going to take either an igneous rock, a sedimentary rock, or possibly even a metamorphic rock. So any of the three rock types can be our pre-existing rock. And then we're going to subject it to the process of metamorphism. A lot of you probably took a biology class back in high school, and you talked about the transformation from a caterpillar to a butterfly. That was an example of metamorphism. Same type of process happens in rocks, although they don't turn into butterflies, obviously. Metamorphism means to change. In the case of geology, what we're talking about is the alteration of a pre-existing rock that's going to occur deep within the earth. And the reason that this process is happening deep within the earth is that's where we have the conditions necessary to make the alteration. There's three things that are going to help us out with that process of metamorphism. One is heat. It's a lot easier to alter the rock if we can heat it up, soften it a little bit, and allow those minerals to kind of move around or change. Pressure. Pressure also helps with changing our rock. And then the third agent of metamorphism is hydrothermal fluids. So let's break that word down. Hydro means water, thermal means heat. So basically these are just hot water fluids, and they're going to interact with the minerals inside of our rock, and they could cause that rock to change or alter and become a metamorphic rock. And then in the end we get our metamorphic rock. Those three agents basically are stressors that are going to take our existing rock, apply some stress, and cause it to change. The three can actually happen simultaneously, so we're not going to talk about them individually. We're going to talk about them collectively. So heat and pressure and fluids oftentimes occur in the same environment. Because we're starting with a pre-existing rock, what we're going to always talk about is what that pre-existing rock was, because that's going to influence the properties of the metamorphic rock that we create. We're going to give that pre-existing rock a special name. We're going to call it the protolith. Okay, before we talk about what the protolith is, let's just think about the word proto. If you think about prototype, proto, or pro means pre. A prototype is just a representation of what something might be. So a protolith is what it was prior to that alteration. So the parent rock from which the metamorphic rock formed from. And again, it can be any rock type. It can be an igneous rock, it can be a sedimentary rock, or it could even be a pre-existing metamorphic rock that could undergo that change process. Metamorphic rocks, unlike our sedimentary rocks, which we could see forming right at the surface of the earth, or at least we could see the sediment accumulation, you can't see metamorphic rocks forming by and large. They're forming under intense heat and intense pressure. They're going to be forming in the lower crust and the very upper mantle, where we have the conditions necessary for metamorphism to occur. So by and large, this is not going to be a process that you're visually going to be able to see. The one exception to that would be something like a meteorite impact. You have an immense amount of heat, an immense amount of pressure, and that's happening at the surface of the planet. But that's really a catastrophic event, and hopefully none of us will live through something like this. The vast majority of metamorphic rocks that you're ever going to encounter are metamorphic rocks that formed deep within the Earth. Why do rocks undergo metamorphism? Well, they enter environments that sort of require it to happen. We've talked a lot about plate tectonics. One of the types of plate boundaries that we talked about was a convergent plate boundary. In a convergent plate boundary, we had subduction that brought rocks down deep within the Earth, that heated them up, and pressure was also present as well. That's the ideal condition for metamorphism to occur. We could have this piece of continental crust crash into this other piece of continental crust. We talked about mountain building. There's another environment where metamorphism could occur. We'll talk a little bit more about those environments. Regardless, it's some kind of unstable environment with a lot of heat and a lot of pressure, and the rock has to change to respond to those stressors. For this video, I'm going to leave you with a thought question. Can metamorphic rocks form through complete melting? So think about it. Could part of the process result in complete melting of the rock? Sure. Nope, not a possibility. Or it's an interesting thought, but no idea. If you think about it, we'd already actually talked about a rock type that started out from material that had been completely melted in the form of magma and lava, and that was our igneous rocks. So metamorphic rocks can't actually form through complete melting. So if complete melting happened, we'd be back to the beginning of the rock cycle to our igneous rocks. So once we put melting into the equation, we're back to igneous rocks. Now metamorphic rocks, when they're undergoing that metamorphism process, there can be a little bit of melting or heating, but if the whole thing melts, we're back to the realm of magma and lava, and then we're going to start over with igneous rocks. So it truly is a cycle.